So today we're going to create something really cool. Okay, we're going to create an in-game level editor. So if you want to have your players to be able to create levels inside your game without having to download Unity or anything, okay, straight up from inside your game, you could do just that. And now, as I'm showcasing a bit the stuff we're going to create over here, let me just mention that of course this is not a beginner tutorial, okay, and of course there is a lot of stuff to cover. So if I forget, I'm going to assume that you know at least more than the basics of Unity, or you at least have an intermediate level of knowledge for Unity and coding. Okay, so because I'm going to need to go pretty fast with this. Okay, so as you've already seen, we're going to focus on making tiles, a grid, and so we can paint the tiles with whatever material or texture we want to have. Okay, so we'll have some few options over here. We also have a paint all, which paints all the terrain, that paints all the textures. We're going to have two types of placeable objects, which is, the first one is we can only have one type of placeable object per node or per tile. Okay, now if I'm saying tile or node, for this case it's pretty much the same for this video. Okay, so you see that if I place one, I also can change the rotation. It deletes the previous one. If it's the same as this, so if it's the placeable objects, it will delete the previous one and add the other. Okay, now on top of that we have the stackable objects, which is for, if you think that now I'm placing a few, I don't know if you can also see it in the video, but I'm placing grass or stuff like that. You know, if you want to place something that you do not care if there is already another game object over there. Okay, so we have a list that we keep placing objects in it. Now let me zoom in so that you can see that what I'm actually saying. And 2D. Okay, this is the stackable game objects. As you see, that you can use them as decals or whatever else you might need. Now, but they do not have to delete the previous placed objects. Okay, so they can coexist on the same tile together. And let's showcase that. So if I place some grass next to the same tile where we have a barrels, we can do just that. Now, okay, this is for adding a bit more detail on your levels. Okay, so it's nothing, it's pretty much optional. Now the other cool thing we're going to actually do is make a wall creator. So if I click on the first tile and where I want to draw a wall, we can do that, just that. Let's just see it once again. Okay, so I can have cool things like that. And the other cool thing I can have is I can make a box with my wall. Now there is no visualization currently, but that's simple enough to do. Okay, and all these cool stuffs we can actually do. Now of course, creating your own level without a way to saving it would have been a waste of time, so we will also see some serialization. Okay, so as you can imagine, there is a lot of stuff we have to do today. Now let's start with the basics. Now I'm going to assume you know how to create the canvas. Okay, and all these are buttons, and all these buttons we have functions that we place them, that I place them. Okay, and we have a level creator script and we use that. Now before we go into the level creator script, we need to see how we can create a grid. Now what is a grid? In case you don't know, this is a grid. Okay, so we have nodes. These tiles correspond into a node which we have inside our grid base. Okay, and we can control how big we want our grid to be and how small also we want it to be. Okay, and they correspond inside a graph, or you can say it's a graph or a grid. They are the same thing as far as this video is concerned. Okay, so you say this the tiles are on the X and on the Z. Okay, so if I want to say give me the tile on the that is on position X and on position X on 5 and on position Z on 7, then it can go into the graph and say this is the tile. I don't know, this is not the tile, you know, I'm just giving an explanation. Now let's see how we can create the grid, but before we do that, we want to create a prefab for our grid. Okay, and our prefab is this floor prefab. Now this is an empty game object, and inside that empty game object we have a quad. Okay, I'm using a quad because I do not want to use a plane, because a quad is way smaller than it has a lot of only two faces, while a plane has, as you know, has 10 by I think it's 10 by 10. Anyway, significantly a lot more. Now my quads also are not on the regular scale, are half a point, they are a point larger, and I also have do not have it on 2, I have it on 0.99 and 0.99 because I want this so you know we will see the wireframe inside, so we can separate, we can know which tiles are separated. Okay, now we also have a node object over here. We will see later what these things are. And let's go into our grid base. Now before we actually go into the grid, we need to create the class of node. We need to go to definition and we need to create a class of node, and in here we will save the node's position on the grid, so on the X and on the Z. Okay, so basically his position on a two-dimensional grid. A game object that is the visualizer, with that thing is the visualization is the quad, not the quad, the actual prefab you see over here. Okay, it's this prefab and where this is placed on the level, because as far as the grid concerned, okay, everything is two-dimensional as far as the grid on the script is concerned. If this was over here and not the background, and this was over here, or this was over here, if we didn't do other calculations from the script, it wouldn't matter, they will still be on the same position. So this will be on the 3x and 2 and 1 z. Okay, 1 because we start from 0. Okay, so this is we basically use this game object as a reference to place other objects inside our list, inside our inside our level. Now the mesh renderer, the tile renderer is the tile renderer, as you can imagine, is the tile renderer of from the prefab. Okay, and I store this because we're using it a lot, and we do not want to to use get component all the time. Okay, a public bool is walkable. This is pretty much for the pathfinding we're going to do on later videos and on later series, so you do not need this right now. Okay, and then the level editor is the namespace we're going to use for a level creator. Okay, so we'll be adding the level editor namespace. And I'm kinda lost. Let's see. Code definition. Okay, and over there we have a level object is a component that every object that is placed on the grid must have. Okay, and we have this is the level object. The placed object is the objects we see over here that can only exist only one in the node. Okay, now I'm separating this from the stacked and the walls because later on I want to have, if there is an object over here, if there is a placeable object that takes one node by itself, I want to remove it from the pathfinding grid. Okay, so these are stuff we're going to use on later videos, on later series, and they're going to make pretty much more sense then. So of course you can do your own way, or your own grid, or your own level editor. Okay, now for the stacked objects I want the same, they take from the same component, but I want to save them on a list because I do not care if one replaces the other. And a component for the wall objects we're going to see in a bit. Okay, so we have our component of the grid, of the node. So we need to create a grid with a double value. Okay, and this pretty much is what creates our grid. Okay, so if we say on the create grid, we say create the grid is a new node with the size of X and side of Z. Okay, these are how big are the grids, how big is the grid, and the offset is how we can place, because I do not have I'm not using one by one. Okay, I have made the scale of my nodes, of my tiles, a little bigger. Okay, I want to be able to calculate that, so I place them automatically, so it's not one over the other. Okay, now my offset is 2, not 1. Okay, since I'm using a double scale, and this is the singleton, so that I can use this class before without having to use get component on every other script I want to use this, because I use this a lot on a lot of the other scripts. Okay, now if you do not know what a singleton is basically a static variable, so there can be only one instance of the script inside my level. Okay, we create a static grid base, basically a class of this, we call it instance. We create a public static function that returns us this instance, and on awake or start, but it's better on awake because we want to initialize other stuff on the instance, on start. Okay, we say the instance is this component, so is this script. So from everywhere, if I go into, let's say, not the resource manager, on the level creator. Okay, so if I want to store the grid base, I do not have to use game object, find game object, and all this stuff, find game object with tag or all this stuff. I can just use grid base and call the get instance function, and as you see, I use this a lot. Okay, so create grid. We initialize the new grid, we say how big it is, okay, and we say we have two for loops on the X and on the Z, okay, and we say the position of the X and the Z, this is the wall position that we're going to place our visualization for the node, okay, so that's why we turn it into a float, okay, and we multiply it by the offset we want to have. We instantiate the prefab, the node prefab, we pass the position, the position we created with the offset in mind, okay, we do not care about the rotation, and we set the game as a game object. We parent it under a transform, but because I also have another transform over here where I keep my other scripts, okay, I just parent it to the second child it has, so it will parent them under the floor game object. Now we created the game object, the visualization for our node. We have we use this in the serialization. So we have a node object component, but we're going to see it in a bit, not right now. Okay, we get the component and we basically store the position of the X and the position of the Z on the node object. Okay, these are for serialization purposes, so we're going to ignore them right now. Now, we have a visualization for the node, but we need to also assign this new node. So we create a new node, a new class of the node, and we set up all the references and all the stuff we need to have. Okay, node visualization is the new game object we created. The tile renderer will be the mesh renderer we find from the node visualization. This is a game object. Is walkable, we turn it to true, although we're not going to see pathfinding in this video. Okay, position X equals the X, position Z equals the Z, and we say to the grid, put this node inside that position inside our grid. Okay, and this for loop creates this thing you will see over here. Creates this. Okay, if I go and change the level manager and say I want size 5 by 5, it's going to create a significant smaller grid. Now I'm going to place this 20 by 20 because it's probably going to mess with my save and load function. Now we have the node, but we do not have any colliders inside our game object, inside our prefab, and that is why, because we do not want to use any colliders inside our prefab. Okay, and that is because we do not want to have, so if this is 20 by 20, it's 20 by 20 is 400 colliders inside our scene. Okay, we do not want that. So we need to create something for our mouse to collide on. So we create a new game object, we add the component of box collider, and we also need to take the component of box collider, and we need to take the size. Now we take the maximum size of the grid on the X and on the Z, of course, and we multiply that by the offset, and this returns us the actual size, and this returns a collider with the actual size that can cover the whole grid we just created. But we also need to place it on the correct position. Okay, so we say the new game object we just created with a collider. Now its position will be the size X multiplied by the offset, so we know how big is the offset. We subdivide that by 2 because the center of our grid is in the center. Okay, it's not in the corner. it's in the center, and we subtract the radius of the grid. Okay, so and we subtract this one, how much we need to go from the edge to the center. -1. Now -1 works on a 2x2 scale for the grid, so you might want to change that. If you have a 1x1 scale, you might want to change that to 0.5. Okay, and the same for the Z. And this plays the game object, that is the collision for our mouse basically. Okay, new game object. If you see, it creates a new game object with a collider placed to cover our whole of the grid. Now, the other thing we have to concern ourselves in this script, okay, now of course we need to include the generic, the namespace, and this is for pathfinding. We're not going to use that on this video, so ignore this completely, and I do not know if I'm going to actually use this on any other video. So anyway, so the next thing we need to have is, from the collision from a wall position, return a node. And that is why, because when we want to click on a node, we want this to transform the raycast hit, we want to transform that into node positions. Okay, so we take the wall position, we take the X and the Z, okay, and we subdivide that by the offset, and we round it to, and we round them to it, because from the subdivision it's going to return a float, and we want to make that into an integer. But since we are going to round this stuff, we want to check if the X is higher than the maximum X's we're going to have, make the X the size X. Else, make the Z, or for the Z, do the same. Or if the X is lower than 0, make it 0, and for the Z the same thing. And we return on the grid the node that has the position of X and Z. Okay, kinda simple. So this is how we create our basic grid. Now this is pretty useful, to be honest, and we will use grids on a lot of other videos. So next we have our grid. Now we need to start placing stuff on our grid, but we need to keep thinking of, let me close that, we need to think of our editor and the way we place scripts and the way we place game object. Basically, we need to think them as you know, that we're going to actually save those. We are not going to be just placing objects inside our scene. We also want to save those. Okay, so for our prefabs, we need to have, of course, we need to have anything we're going to place on a script saved as a prefab. Okay, and I also have this categorized for our, you know, for our help. And let's drop the object planks. Now over here you will see this is the object planks, is that where we actually instantiate the game object, but the models go inside a different child game object. Okay, and all this have with LODs and all this stuff, whatever you want to have, and this object is an empty game object that has the model inside, and this in turn has the game object of level object. Level object. Public string object ID is the ID of the object we want to, the unique ID basically for the object we place. how we make that? We go into the inspector and we write the unique ID. Now, I keep the same names as the names of the prefab. Now, of course, you can automate this stuff. Okay. So I keep the same names as the prefab, so so that we do not get lost. And why we need unique IDs is because we're not going to be assigning game objects, in public variables from the inspector, so that you can paint. We will create a level resources. I have it inside my level manager or level resource. Doesn't matter where this resources manager is, because we're also making this a singleton. Okay, so we have this resources manager script, and inside it we have list with all our prefabs. So for our object planks over here, which is this, I have an entry that says object planks, the object ID, the string, and the object prefab is the prefab we're actually creating. Okay. And let's see the other variables we have. The grid position on the X and on the Z, I'm pretty sure you can understand what this is. Okay, where they are placed, the node, where they are actually placed. The game object model visualization is the model. World position offset, I'm not actually using this, but if you want to have your players offset the local position of your objects, okay, you just add another variable, but keep in mind you have to also save that. Okay, and world rotation is the rotation of the not the node, not this game object, okay, the models. Okay, and rotate degrees is when you place it, when you place an object, how much you want it to rotate. Now it's rotating with the right click. Okay, I have this on 35 degrees, but I have the planks on 90 degrees. Okay, this is completely how you want to use it. And now, before we move on the next variables and the next functions, let's see the resource manager. So resource manager is this which calls all the lists. Okay, we have three lists over here: level game objects that are stacking. Okay, whenever you see game object stacking, means that we do not care if we can have multiple of these game objects on the same node. Level materials is all the materials we can use on the terrain, and the wall prefab is the prefab we use for the wall. Now we set up the singleton for the resources manager. Okay, keep in mind we also include this on the level editor. And so we set up the singleton, and we have some public variables over here. Now, level game objects base. Level game object base is this class, and level stacked object base is this class. Okay, it's basically a serializable class that has a string and the object prefab where we are actually going to be instantiating. So when I want to instantiate a game object, I do not use instantiate, throw the prefab and use that. I have to come inside this script, search the list of game objects, and compare the object ID. And if it's the same object ID with the entry we have on the list, it returns me the object prefab, and I can then instantiate it. So we need to automate that. Okay, we do not want to be searching all the time for the same game object. Okay, so we've created these three functions, and we say a public level game object get object base. We pass the object ID. This is what I've just explained. Okay, we have the return value. We set it as null from the start, and we say search inside the level game object list, and if the object ID equals the object ID we are passing with the entry, okay, return the level game object, and then break the for loop, so do not keep searching, and return the return value. Okay, for the stack object base, it's actually the same, but we're searching on the level game object stacking list. But the material and the material ID is kind of different. We want to get the material based on the material ID. Okay, so we pass the material ID, which is an integer. So we have a material, and we say if the integers are of the entry and what we have passed are the same, then return that material. Okay, break, return value. But because we also need to save that, we need to have a way to save all the data, so we need to know where that material is placed on the list. We also have a public integer, a public integer that we can pass the material in, and it goes searches the list over there, and it returns the ID. So the comparison over here is material with material instead of integer with integer. So this is the resources manager. Let's go to our level objects. Let's continue. So what we have up till now, we see how we can create the grid. We see where we keep all our resources. Okay, where resources are the game objects that can stack, the level materials so that we can paint the tiles, and the wall prefab, which is the wall creator we're going to see a bit later. Okay, we know where this game object belongs on the node, so we need a function that says go into that node and update it. So we have a public function update node, and we pass the grid. Okay, from wherever we're going to call this function, we need to pass the grid. We find the node from that grid. Now, of course, you could use that. You could skip the part of passing the grid and pass just the node. Well, anyway, okay, we need to find the wall position, and we pass the visual. We go to the node. We find the visualization model, and we pass the transfer position. Now you want to apply the wall position offset, but anyway, this is kinda silly. We not need it, but let's keep this in here anyway. And then we say we change the rotation with the wall rotation, and we say the transfer dot position is the same as the wall position. So this is what actually goes and places the level object upon a node on the grid. Okay. A public function if we want to change the rotation of our game object when we are placing it. Okay. Takes the Euler angles and adds with the rotate degrees and adds it to the Y, and then change the local rotation to the Euler angles. Now, of course, you could probably just change this to the model visualization. Now, of course, there are some bugs over here. And all this stuff is for the serialization. We have a class which is the saveable level object, and these are all the variables we want to save. So the next time we load, these are the stuff we need to know. So we have a list that saves all this stuff, the saveable level objects, and on load it repopulates this list. Okay, so how will I know that what model to instantiate for this level object? We use the public string, the object ID, where this object is going to be placed. We use the position X and the position Z. What rotation you need to have? These floats. Now, these floats are because you cannot save. Pretty much keep it when you're saving it. Just keep it on using primary values. Primary values are string, int, float, booleans. Okay. So you need to break the rotation into floats, basically. If it's workable or not, pass it as false, and if it's stackable or not, pass it, initialize it as false, not pass it. Okay, and this is the public class, saveable level object. So for each level game object, when we want to save, we find all the references, all the types of level object inside our script, and we call this function, and we say get saveable object. So basically it creates a class with all the information we want to save and assigns it. Okay, not a lot of stuff I need to explain. Okay, I'm pretty sure you can understand it, what this does. So we have our level objects. Now for our button, so we have our level object, so we need to create something to place them. Now let's get some stuff out of the way to eliminate the problem where I'm placing a game object with the click and I'm over a UI element. Okay, if I click over here, it won't place the object. Okay, this will not happen from the start. You need to actually create this. So what I did is I have a background, and I also have the interface manager. Interface manager is a singleton, as you can see, and it only has a public boolean of mouse over UI element. So if on our level creator script, if this is over a UI element, it does not instantiate a new object. So, and I also have two functions, two public functions. Mouse enter, make the mouse over UI element true, and on mouse exit, make the mouse over UI element to false. Okay, and we go on the background and you will add an event trigger. Okay, add component, event trigger. You click the plus, drop the game object where it has the script, and you go and find it over here, and you will say interface manager, mouse enter, and mouse exit. Okay, let me delete that. Okay, and pointer enter, it enables the boolean of over UI element, and pointer exit disables it. So, and that will eliminate the problem that when you click over a UI element, it does stuff it wasn't supposed to do. Now, let's go directly into the level creator. Ignore the Pathfinder. Level manager, right now it's also a singleton, but the only thing that it has over here is that it has 3 lists that go and place everything we create, but we're not using it anywhere else. So you might want to ignore this, but you probably want to know what game objects you placed, because you need to create colliders, make them batch the colliders, and there are other stuff you can do with this. But for this video it's not really necessary to use this. So ignore the level manager and wherever else you're going to see it, and let's go into the level creator. And this is where the meat of everything is. And we say, okay, we need to store, even though they are singletons, we need to save the references. No, we don't exactly need it, but let's save them so that we can save some time. Okay, so we say on start, get the grid basic, get the instance, level manager, get the instance, interface manager, get instance. And I should probably have the resources manager over here too, but anyway, we'll see in a bit. Let's see if we want to place an object. Okay, we are going to use all these variables. If we have an object, if we have the object to place, the clone object, so that we visualize. So okay, it follows the mouse, and when I click, it creates a new clone, as you see over here. Okay, the game object that follows the mouse is also an instantiated game object, and that is the clone object. The object properties, mouse position, world position. Okay, you understand this. So on update, we have all the functions we're going to create. Update mouse position does a raycast from the mouse inside our scene. Okay, and assigns the mouse position. If it hits something, assigns the mouse position to the hit point. And we go over here. We need a public function to say from the button, if you click this button, start placing objects. And this is it. Pass game object to place. The string, the object ID, we pass it. With this, we write it from the inspector. So if I go to my level editor, if I go to one of my objects, okay, and I have assigned the level manager over here and the level creator pass game object place, and I can write the name of the game object I want to instantiate when I'm creating this game object. So I have the same name. I've written the name, the object ID of the game object, and that name is object barrels pack 1. Okay. If we have already pressed one of those game objects, if we already have a clone object, so if it's not null, destroy the clone object. So destroy the previous clone object. Close all is a function that closes all the other functions. Okay, has object false, delete object false, paint tile false, place stack false, create wall false, has material false, delete stack object false, delete wall false. Okay, so we need to close all the other functions, and we need now go and create and enable the function we actually want to use. So in this case, we need to enable the has object, and we turn that to true. We say the clone object is null, even though we have destroyed it, it might not make it null. It might go make it as a missing reference. And the object to place, we call the instance of resource manager, so we call the singleton. We use the function of get instance, and we use the function of get instance to take the singletons to get the instance that is inside our scene. And then we call the get object base object ID. We pass the object ID, so it goes into the resources manager. It goes into this list. It finds the game object with the same object ID and returns us the prefab. Okay. And this is the resource manager, the level creator, and it returns us the prefab, the object to place. And this in turn, since we open the has object boolean, it goes into this function that only works when the has object is true. Okay, and it starts all this. So we start, of course we need to know where the mouse position is. Okay, so we use the update mouse position function. We say we need to find the current node where the node the mouse is over, and we use grid base node from wall position mouse position wall position. We turn we find the visualization, the wall position from the visualization of the node. Okay, so we use current node.vis transfer.position, and we say if the clone object is null, so we do not have a game object, the clone game object. The clone game object is the object that follows around our mouse. Okay. Then instantiate object place on the wall position, and we do not care about his rotation. And store the object properties from the clone object we just created. Okay, the wall position is updated by the position of the mouse, and we take from the position of the mouse we take the new node, and then it updates the wall position, and so on. If we have a clone object, that means we are pretty much ready to place a game object. So clone object transfer position is the wall position, of course. And when the player clicks the left mouse button and he's not over a UI element, okay, we talk about that. Then if the current node does not have a placed object, so it's not equals null, the placed object of the current node is not equals null, then go to the manager and say in the list in scene game objects, remove the placed object, the current game object that is on the placed object of the current node. Okay, destroy that game object and make the current node placed object to be null. And then we need to instantiate the actual game object that we're placing. So we're not using the clone object. We are basically cloning the clone. Okay, so we say we create a new game object, actual object placed, and instantiate the object to place, where we find that, on the wall position, on the current wall position, and we pass the same rotation as the rotation of the clone object. Okay, we of course cast it as a game object. And the level object, we need to change the properties to the new game object we created. So the placed object properties, we say the actual object placed, we get the component of the actual object placed, and we go and update the values we need to update, such as the position it has on the grid, on the X and on the Z. Okay, on the current node we change the placed object with the placed object properties, so we basically assign the placed object, Okay, we assign the properties, and then on the manager we just go and say instance game objects dot add the actual object placed. Okay, if the player clicks the right mouse button, it goes into the object properties and it changes the rotation, so it will go into the level object and it will call this function and it's going to change its rotation around. Level creator. Else. This else is from the has object. If it doesn't have an object, okay, and we have a clone object, then destroy the clone object, because we do not want to use it anymore. Let's say we want to delete the placed object we need to have. Okay, we need a function to call from the buttons of the UI. Okay, close all, delete object equals true, and it enables this function if delete object. We also need to update the mouse position. We need to know the node the mouse is over, and if we click the left click and we're not over a UI element, and if the node the mouse is over is not empty on the placed object, so it does not have this variable assigned. Okay, if it doesn't have anything, it's not going to do anything. If it has, then it's going to go into the manager and it's going to go into that list and it's going to look if it has this game object, and if it has, it's going to remove it and it's going to destroy it, and then it's going to make the current placed object to be null. And that is how you delete the objects we just placed. So up till now, if you followed along and if there are no problems, and of course if I didn't forget anything, you will be able, of course you need to assign the functions into the buttons. You'll be able to go and come and do this. Okay, and if you want to delete, and you can just delete it as that. Okay, and it's pretty cool, I believe. So before I move to the next objects, I'm going to break the video apart and I'm going to take a little break and I'm going to create the next one. So I'll see you in a bit.